Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. Not every app is built using best practices. Sometimes you have to try and fix an application that's been poorly maintained for years or even decades. Adding dependency injection and inversion of control, or IOC, is a great example of this kind of situation. In this episode, we'll discuss the process of adding dependency injection and inversion of control to an existing legacy app while the app is still in use. We'll talk about how you might approach this process without causing significant disruption to services. But before we get started, Will, what have you been fighting this week?
Well, we're kind of stuck at the house. I'm trying to think when all the different orders came down, but basically it's like, don't go anywhere, don't gather in groups of, I think, more than like 5 or 6 people or something. And the grocery stores are out of toilet paper. They're out of milk half the time. You know, everything's really screwed up. I've been sitting at home, and I think you and I had this discussion the other day, just like how many people we know that are talking about how much free time they have all of a sudden. And we're like, we don't have any at all.
Yeah.
And it's worse than it was. So yeah, that's the main thing going on, is just kind of trying to wait out this virus, and hopefully it'll, get to a point where the economy can go again soon. Somewhat has been nice just to be in a little bit of a slower pace of life, even though I feel like I've got more work to do. I don't know. It's a mixed bag. How about you?
Life is crazy busy right now. I mean, I realize, like you said, that's the opposite of what most people are doing during this quarantine. I'm on a project at work. So even though I'm full remote now, I'm spending more time in meetings, which is taking away from my time to code for it. Because, they decide that, hey, let's put a meeting right in the middle of the day. Had a noon meeting the other day. And I'm like, no. Like, I sent a message to one of the lead developers. I'm like, do y'all want me to build this, or do you want me to sit around and talk about building it? Because I can only do one.
Yeah.
Like, there's only one of me, so I can only do one of the two things. And he was like, I don't know why you got invited to that meeting. I'm going to it. Don't worry about it.
I've had I have a noon meeting 4 out of the 5 days this week.
Mm-hmm.
Of course, my crew is on Eastern time. So it's like, well, you should eat lunch earlier. And it's kind of like, well, you can't necessarily because you're not hungry.
Yeah. Well, I don't like middle of the day meetings, because sometimes I'll eat something around 9 o'clock in the morning because I know I'm going to get into it, and I will sit at my desk and work till 1 or 2 before I take a lunch break.
Yeah.
Because I'll get going, and I'll be like halfway through something. I won't want to stop. Like today, I was adding in the security for this new application, and I'm like, I did not want to stop halfway through building out, this authorization and authentication protocols.
Yeah.
So I'm like, no, I'm going to push through, and I'm going to finish this. Then I ate lunch around 2 o'clock today.
Yesterday I ate lunch at 5.
Yeah. But, on top of that, since all of the classes at school are now online, I'm no longer an afterthought to the in-person students.
And I bet that's not positive, is it?
No, it is not. Now they're expecting me to go to class in the middle of the day online. And I'm like, you didn't start the semester out like this. We're over halfway through the semester. I'll have to ask permission from my boss to do that, is what I told the professor. I'm like, you changed. Like, I understand that you have to do this for the in-person students because that's what they're expecting. But I'm like, I have a routine. I have a job.
Yeah.
And this class meets right in the middle of the day. I wouldn't have taken this class, had I had to go on campus. Of course, it's an hour and a half drive one way, but that's why I take stuff online. I'm like, and it's online, so it should be able to do that. And, before that, I was able to get by with like doing the work between times, like say, like when Amanda was at work or something, I could be, oh, hey, I'll do my schoolwork and stuff. And it's just it's a pain. But I will say, hey, on top of all this and with all this, I guess, in really cooler news, our church is streaming all of their services. And with my experience live streaming, audio mixing, videography, and computers, I'm on the select production team with the required skills to get the job done. Do you remember that scene from Fifth Element where the general comes in to get Corbin Dallas to do, like, to go on the mission, and he just has this like long list of requirements that falls all the way down to the floor as he starts reading them off?
Yeah, I do vaguely remember that.
And it's like, of all the members of your team, you're the only one qualified. Also, of all the members of your team, you're the only one still alive, but we're not going there. But that's kind of how I feel. And like, the few of us that are actually there are all the ones who have the skills needed. I'm loving it. I really am. But none of us have gotten much rest since all this started. I know the other tech person on the team is putting even more work than I have because, well, she's already got her master's, so she's not in school. She was also already working remote, and so she's got a little bit more free time to devote to it. So like, whereas my free time is split between school and church, and Amanda, hers has all been church. So it's just, it's been a lot of work trying to get all of this done. These things that we had been talking about doing and had planned on spending, the better part of a year building up the skills and learning the things we needed to learn to do them, all in the matter of a week or two.
Yeah, that's the worst, is everything is compressed.
Yep. I need a break, man. I really do. I was supposed to go down to Huntsville for the We Rock IT conference, but I think I've already told you guys that was postponed. Amanda and I were going to go anyway because of the Airbnb that I had gotten and just sort of hang out, maybe check out some breweries. But that's not going to happen anymore. Can't really travel. So I actually think I'm going to just take the days that I requested off, at least take Friday and just relax.
Yeah, I've considered doing that same thing. I just don't know when.
All right. So if you guys listened last week, we switched things up a little bit. And so we're going to keep doing this. Since we're talking about Will's book, he's going to go ahead and get on into it in book club.
So in the second chapter of my book, Remote Work, The Complete Guide, I describe how remote work provides companies a competitive advantage. Now, bear in mind, I wrote this before the whole coronavirus stuff started. And so most of your companies right now are getting a total baptism of fire with this thing as it is. But I get into why a company might want to hire remote workers. And the main thing here is understanding the incentive structure that helps a company decide that they want to hire people remotely. So there's several different things in play here. There is acquisition and retention of employees. There is resilience to disaster. There's a lot of things obviously there. With that, we're seeing right now that when we have a pandemic, the companies that allowed remote work have been able to transition to it, 100% of the time fairly easy, whereas a lot of other companies are not doing so well. There's other things involved here too. They get a larger hiring pool out of this. They get a lot of organizational resiliency in terms of time zone, in terms of not just natural disasters, but in terms of like holidays and all kinds of other stuff. It also lowers their cost of office space. They can get employees at a cheaper rate. There's just so much stuff that remote work can actually do for a company. And I wrote this section of the book with the intent of helping people convince their companies to let them work remotely. And now I kind of feel like a lot of that convincing might have actually been done. But we'll have a link to the book in the show notes.
So we grabbed a comment of integration considerations from, I'm thinking it's B. Hanuk. Looks like the B is probably a first initial. It says, "Hi guys, fantastic episode as usual. Any book recommendations for this topic? API design, integration security, availability, etc. Thanks."
Yeah, there's a book called Enterprise Design Patterns that gets into a lot of how you make distributed systems work well together. That's going to get you a pretty good chunk of the way as far as maybe some things you're not thinking about in terms of API design and availability and those kind of things. It's more geared to how you mitigate problems rather than how you don't have them. Once you get a distributed system, you will have problems. You can write a certain degree of code to avoid the problems, but for the most part, it's just living through them that actually matters. So I would strongly suggest, that book. There's probably a few others, but I can't recall off the top of my head. But that one will get you a long ways.
Hey, that's great. Thanks, man. I'm gonna have to look into that one too. If you'll send me that, I'll try to get a link in the show notes too.
Okay,
Because that's a great recommendation. We may do that for book club sometime. Thank you. We really appreciate the comment, and that's a great question. Send us an email to waterbottle@completedeveloperpodcast.com because we've got a Complete Developer water bottle just for you. And guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all of our episodes to Facebook, Twitter, and LinkedIn. We're also on Instagram and Tumblr. You can join the conversation anytime via Slack by going to slack.completedevelopernetwork.com. Your advertisement could be here. If you like the show and would like to advertise on here, send us an email to adverts@completedeveloperpodcast.com. We have short-term, long-term, and other sponsorship opportunities. Reach out to us and let us help you reach the people who you are serving, especially in this time of quarantine when they're all just sitting around listening to us talk.
When you get dropped into a legacy project, one of the main things you'll miss is the use of more modern development practices, such as testing, inversion of control, proper object models, and configuration management. However, you probably can't simply stop active development for 6 months to re-architect your entire application. This is especially risky if you don't have a proven track record of reworking applications in this fashion anyway.
The code is never the most important aspect of a business, no matter how important it is to developers. While working on old, crappy systems is generally stressful and doesn't help your career much, unless, that's what you do for a living, it's really hard to get the business people to care about it. However, you can usually get away with making incremental system improvements as you go about your regular business. If you plan these improvements well, refactoring can make your work easier, giving you time for further improvements.
Adding dependency injection and inversion of control is one of the first things you'll probably do as you refactor a legacy application to make it more maintainable. In this episode, we're going to discuss why you would want to do this and then give you a practical plan for doing so, taking into account the fact that you are working on a running application that has to work the entire time. We'll also talk about some things you should probably have in place before starting on this process. Finally, we'll get into the nuts and bolts of the process, along with explaining why we're doing the steps in this order.
So first thing we're going to talk about is why you even want to go about putting this kind of work and effort in.
Well, it's because the work and effort is going to happen no matter what you do, right? Because if it's a legacy app, like you're going to maintain it and it's going to be hack on top of hack eventually. So you're going to have to do the work anyway. But what this thing does is it gives you an improved ability to quickly change the app without having to worry about breaking so many things at one time.
Yeah, when components are pluggable, it's easier to switch implementations across the application as you need it.
Yeah, and you can even control configuration dynamically from settings, which simplifies a lot of your code. So instead of having to do a check and go, if it's this flag is set, do this. If this flag is set, do this. You just go, hey, just give me the thing that handles that strategy.
Oh yeah, I have seen some code that I just looked at and I was like, if we just moved this out to the configuration, then anyone from ops, when a change request came in, could just go in and do this, and it would take them 5 minutes, as opposed to the whole process taking 2 weeks because they have to submit a request. It has to go through the change management system. get to a developer has to pull that card, make the change, and then push it through testing, when it was not anything that, like, it shouldn't have been a code change.
Right.
Should have been a config change, and you could have saved a lot of time. Just seeing a lot of stuff like that because things weren't built with that in mind 20 years ago.
Yeah. I will say that around like 2004, 2005 timeframe, a lot of the .NET stuff was built that way, but it was all XML configuration based. And, it was really dense, nasty XML. And so people didn't do it. And so they kind of dropped that.
Mm-hmm.
But yeah, it's worth doing. Another thing that this will help with is your object lifecycle management. What we mean by that is how long a particular type stays alive in the app and in memory. More than likely, if you're on a legacy app, you're not maintaining this.
Mm-hmm.
Your app is probably not managing things like network sockets, database connections, file system access, open files on the file system, those kind of things. The number of those that are open concurrently or that stay open longer than they should is probably pretty high. I've worked on apps that had tens of thousands of calls to the database that were like SP reset connection because stuff was transiting the pool too much. I've also had them that just flat out leaked database connections and would eventually take the server down. And so it's really worth trying to fix lifecycle management as a result of this. A lot of these things get encapsulated in objects that you use, and getting rid of those objects from memory gets rid of the underlying resource that you've allocated. So what tends to happen over time as people get sloppy, those objects end up hanging around longer than they should, or they end up getting created more often than they should. And this happens a lot in garbage collected languages. So like Java, C#. If you're not really careful, those objects can still be around even if you think that they're out of scope and deleted. They're just kind of hanging out there.
Mm-hmm. And you can manage the lifetimes of your objects in a really good way by using policies to make sure that they are kept around for just that unit of work.
Right. Instead of for the length of the app or something random.
That's one of the things I really like about .NET Core. The way it's got its dependency injection set up is you can, when it creates an object, it can be a singleton that lasts for the lifetime of the application. It can be scoped to last the lifetime of that call, or it could be transient to last just for its one use.
Yeah. And you can also make your own policies as well.
Yeah.
Which is also kind of nice if you've got like a service-based application that's, it's running 50 records at a time and then it needs to deallocate some stuff so it's not hanging on to things for too long.
Mm-hmm.
That can be really helpful. Another thing that's helped by this is your testing process. Because you can switch implementations that are being used, it's a lot easier to use mocks and stubs than it would be otherwise.
Mm-hmm.
This tends to really simplify your testing code because instead of fully implementing the object that you're trying to mock, you only really need to mock the methods that you're actually using before passing that in. Instead of having a global mock type that you built up, you just do a quick and dirty mock with a library.
It's also nice to be able to mock some of the slower objects with faster code that returns more quickly. And this makes your testing faster. It also allows, like, unit testing should be testing that one unit of code. So you don't need to test the things that's calling. You just need to test that it's making the call.
Right. And you don't want to expose your tests to network outages and those kind of things either, because that you get flaky tests and then people start ignoring them.
Yeah.
The other thing about dependency injection and inversion of control is that it's pretty much a necessary precursor for modern application development on an object-oriented stack. So most modern OO frameworks make fairly heavy use of dependency injection and inversion of control. It's just built in, just the way it works. And most modern frameworks can be configured to use IOC in a relatively transparent fashion when communicating with your application components as well. So if you hook this stuff in, your app will work like the rest of the ecosystem does. You get a new developer in, they're not going, why is it built this way? Well, because we built it 15 years ago.
Mm-hmm. Yeah. Next, we're going to talk about just a few prerequisites to doing this. So the first thing that you have to have is a data access layer.
Yeah, I would say that you could get away without it. It's just really going to be awful.
Yeah.
You can do just about anything. It's just how bad does it hurt?
Yeah.
Yeah. This whole process is a lot easier if you separated out your data layer. And by the way, it's not just your data layer, it's really calls to external resources. So database calls, network calls, interactions with a file system, interactions with other APIs. Those things add a lot of complexity when you don't really want to deal with it and you're not in a place to be able to deal with it a lot of times.
Also, a lot of applications mix their business logic in with these calls. So you have to separate the two when you're refactoring just to make the code base easier to understand and read. Like I was recently looking at some stuff. I did a training on, is it Stitch or Switch? Something that ends with an itch from MongoDB and starts with an S. I think it's Stitch. Yeah, because I think I made the mental joke Lilo and Stitch. Anyway, I have to look it up to remember. But basically, it was supposed to replace your business layer. And I'm like, so I was talking to the other friend of mine that was in the training with me. I'm like, so you're basically putting all of your business logic on the database now? And what it came down to is that is designed for those really for the early parts of a startup where you need to get something out quick, and the big things you need to focus on are your UI, like the way it looks, and your back end. That middle tier, like that business logic, isn't as heavy in that early phase. So it's just sort of, especially for like CRUD apps and stuff like that, it's a good quick get it built up, like get that proof of concept, and then you can go build something more resilient later. And I was just like, it just irked me.
Yeah.
And this is newer stuff too.
Yeah, well, we're making all the same mistakes we used to make, right? It's just we're doing it with newer tech.
Mm-hmm.
And like, if you're in tech long enough, you'll see like 4 or 5 iterations of this. And you'll just be like, all right, that's that mistake again.
Yeah.
Yeah, it's loads of fun. Another thing you need to be doing is you need to be refactoring to interfaces. So if your language of choice allows it, make interfaces for as many of your own types as possible, and then use those interfaces instead of using the types directly.
Yeah, this is one of the cleanest and easiest ways to switch out implementations without really breaking anything. I mean, you call the interface and then you just change what implements that interface. This does have a bit of an overhead for developers in most IDEs, though. So just make sure that your team knows how to deal with it before you get in there and do it.
Right. So like in Visual Studio, instead of control click, you have to right click and go to implementation.
Mm-hmm.
That's basically it. But there's some people that just breaks their world. So you're going to have to just be prepared for that, because every team has that one dude. And speaking of teams having that one dude, another thing you need to get is your testing. Testing has to be working at a reasonable level. And that doesn't necessarily mean end-to-end automation, but you need a QA department at the least, and you probably need some automated tests for the critical parts of the system. The stuff that you're about to mess with is really deep in the guts of the system, and you're going to break things in ways that you cannot predict. This goes really, really poorly if you have some tester dude who's got 4 other jobs, and he only tests the happy path and only tests stuff that you think you might have broken because he's overloaded.
Yeah.
That guy will not catch the things before you break them in production. And then management's going to come down on you and go, why are you doing all this abstract stuff that doesn't provide value that they can see? And you just broke production. Like, that's a real bad place to find yourself.
Anytime you break production is a real bad place to find yourself.
Yeah.
All right. So next, we're going to talk about wiring in your DI IOC setup to your application start process.
Yeah.
This is the first step, and you need to do it in a way that doesn't cause any problems, especially in production.
Yeah. And this is surprisingly annoying with a lot of frameworks. With a lot of them, it's as simple as downloading a package and then maybe adding a line of code or two within some constraints. Now, if you're using a legacy app, and those kind of ecosystems, even the easy path is really not necessarily as easy as you might think. A lot of times there's a fair bit of configuration just to get started, and you have to get it right for it to work at all. And that includes your app, even if your app isn't using DI and IOC because you crash startup. Another thing that will burn you here is getting this stuff to play nicely with any configuration management system that you have, like reading settings, those kind of things. You're going to have to figure out how that hooks together.
This can be tricky due to the timing of this step. Also, you have to think about when to hook this stuff up. This step may depend on other parts of the system. And it's one of the annoying things about following a tutorial that is not well written or something like that that's using DI is it'll have, all right, put this in your startup.cs class. But then
where?
Well, no, it shows you where, but it's like you put it in there, but you haven't built it yet. So it's like, but you don't the next step isn't building it. So it'd be one thing if it were, and I just dealt with this today. It'd be one thing if it were, okay, put this in the startup CS and then, you right click it and go, hey, create this class and go build it. No, it's put this in there, then do these other things that all completely break what you're working on until you go build this other thing. That is 5 steps later. And I'm like, why didn't you have that first? Because building that wouldn't break anything, wouldn't change anything. And then you put it into place.
Yeah. It's not like the order of typing matters.
Yeah.
But tutorial authors, at some point we really need to do a podcast episode on how to actually write a freaking tutorial. Because I just want to have that as a link I can send to people. But the other thing that really gets you here is the timing is weird because okay, I need to read from a settings file. Okay, well, to read from the settings file, I need to know where that file is. And if the thing that tells me where to find that settings file is a pluggable thing that's used by the inversion of control system, but the inversion of control system requires the settings file, I've got a problem. Right?
Yeah.
And so you're going to slam into this stuff just over and over again, getting it in there in startup. This is probably the hardest step to do.
Yeah.
Additionally, you're going to have to get logging and instrumentation here if you want to cleanly troubleshoot problems that occur. As the process of built-in management of errors may not be working at the point when you need to have the IOC in place, which is also lovely. So you got to do sometimes separate instrumentation from what you would normally do in the rest of the app just because, hey, those things don't exist yet.
Mm-hmm. Yeah. Error handling reporting class is determined dynamically by your IOC. So what happens when the container spin-up fails? These are things you have to think about.
Yeah, I think it's boom.exe. That's what that is. Or you get a memory leak. So yeah, or you get all kinds of fun stuff. The other thing that will happen is that the framework that you're using will get in your way. Even if it's designed with this stuff in mind, there's going to be something there that you're like, why did they do that? And there'll be some weird little edge case that they thought of that you wouldn't think of or run into in a million years, and it's there. A lot of legacy frameworks also are just not built with IOC in mind at all. And so you can get anything from a lack of appropriate application lifecycle hooks during startup to frequent use of static types to sealed types that you can't extend and that there's no interface for, to just weird old ways of managing objects, especially if you're in .NET and you're having to call into COM objects, like the old school stuff from the 90s. They did a different management on that stuff. And so you're going to get burned a lot there, especially if the code is older stuff.
So the next thing you're going to want to do is configure third-party code in your IOC container. Third-party services need to be done next because they often present unique issues. Their dependencies can have their own configurations that you have to deal with. And they may also make direct calls to libraries that you want to mock.
Yeah, and mock, we mean by, make a fake, not just like make fun of it. Although that library could potentially be something you want to mock the other way too. Sometimes it's actually impossible to mock them at all due to the way that they're built. Sealed classes are really bad for this, and your mocking framework has to do all kinds of gyrations to get things into a shape where you can mock it. And usually that's the professional paid version, and your boss is probably cheap. Yeah. And you don't have that.
And the non-overwritable classes is an issue I ran into just yesterday.
Yeah, it's so much fun.
Yeah. You also need to be especially careful about object lifetimes. Third-party components are built with some assumptions about how they're going to be used. And you want to try and match those assumptions if you know what they are, especially the ones about object lifetimes and stuff like that as closely as possible.
Yeah. And by the way, that you kind of hit the important point. More than likely, they're not going to be explicit about this. You're going to find this out by having something break.
Yeah.
Yeah. It's like finding out something's flammable by lighting it on fire. It's like, yes, you proved it, but you have a fire now. It's not really a good place to be. If you do this wrong, you're going to get really hard to debug errors. So you get stuff like memory leaks, access violations, threading issues, timing issues, those kind of things. You might even get data corruption. So it's really important to get this right, and it's really hard to prove that you did.
Mm-hmm.
You also have to be really careful about the dependencies of your third-party types. So, for instance, these libraries themselves may have dependency injection systems of their own that may not be compatible with the way that you're doing it. They may not be compatible with each other, which is so much fun to deal with. For instance, you might find that the library that you're using relies on a data access framework that isn't IOC compatible at all. And it just makes straight line calls to that thing. What are you going to do when you need to mock that data access?
Yeah. This might make it difficult for you to induce situations in the library to see what happens when they occur. So your testing is going to be a pain. This can be important for situations like time changes, leap years, when you want to test before something happens.
Yeah, you don't want to be like testing on 12:01 in the morning on February 29th to go, does this thing work with leap year? Like that's not good. It's like, is this vest bulletproof? Ah, shucks. Don't do that. That's a bad place to be. So once you've gotten this stuff out of the way, now you're starting to get to the part that people start with, and it's the easier part, but you should wait to do this until the other prerequisites are in place. Now you start configuring your own services in the IOC container. So what I mean by service is basically anything that is not user-facing, give or take. So I'm using an extremely broad definition of service. There's a couple of approaches here. One is to configure them all immediately, and the other is to do it as you get to that thing.
Yeah. So if you configure them all and slowly switch over to using that configuration type by type, it limits the scope in the IOC container that you have to worry about.
Yeah. And it lets the QA guy just kind of test a smaller subset of things, and there's fewer things that can go wrong at once.
Right.
So you're less likely to get caught if you're having to do this in a sneaky way.
Now, if you just switch things over as you find them, there's a bit less upfront work, but potential more debugging as you find lifecycle and uses problems in the app. So it's a matter of kind of where you want to put the work.
Yeah.
And where you can put the work too. Some of it is just limitations on how much you're able to do at a time.
Yeah, this is one of the things that's not really decided by what you want to do or what's even best. It's decided by office politics.
No.
Just straight up. Like, you're going to have to work around those. Realistically, you're not going to pick a strategy based on what's best. If you do, you're going to get burned. Like, I've done that before. I would not suggest it. Do what you can get away with in your environment, in a way that you can get away with it, instead of the best solution that you can't get away with.
Yeah. Now, as we kind of already implied, doing it all at once will make the rest of the process a lot easier. If you can do it this way, that's the best way to do it.
Yeah.
However, you are potentially looking at weeks or months of steady, annoying work with literally nothing to show to management unless they really understand what you're doing and why.
Right. And they also don't have something to show to their manager either. So even if your immediate manager understands it, their boss may not. It's great if you can get away with this. I think I've done it once. Like it's right up there with switching out the underlying database as far as you just don't get to do things this way most of the time.
Yeah.
Another thing that's going to happen when you start configuring your own services, especially in a legacy app, is you're going to find that you have static types. So you don't create an instance and pass that instance around. It's just, whatever dot, do the thing. And you're going to have to refactor those places.
Mm-hmm.
You just have to fix those types so that they're no longer static, whatever that happens to mean for the application. If you can't refactor, then you need to introduce a abstraction around it that calls that static code so that you can work with that abstraction instead of the underlying static piece. And this is difficult at times because a lot of times they're using static types as basically global variables and not calling them that. Which, by the way, a lot of apps do the same thing with databases too, right? Like a database is just a complex global variable if you think about it.
I hadn't thought about it like that, but I could.
Yeah, and you don't really want to think about that one too much because it's a long way down to the bottom of that well.
That's complicated. Yeah, I think most of the places I see static types are in extension methods.
Yeah. And extension methods in C#, by the way, are a great example of something that everybody loves until they have to test it.
Yep.
And then they hate it because it's static. And what are you going to do?
Mm-hmm. Yeah. Well, what you do is you have to build them properly, basically.
Yeah.
You don't want any state changes going on in a static extension method. It's literally to do one specific thing. You got to follow the other solid principles there.
Yeah, and it has to be stuff that you wouldn't want to mock.
Yeah.
It's like utility methods, stateless utility methods that, are just, straight up functional. You can get away with it.
A lot of times what I have used them for are converter methods. Like if I'm converting one type to another or something like that, one class to another, or sometimes like checking, like a validation type thing.
Yeah. And I would probably not do either of those that way, but just because of the testing aspect. Although usually by the time that becomes a problem, it's like, look, I've fixed all these other things. Let me just go fix this.
Well, the thing with that is though, you can still test that because you're not mocking anything to test it.
Right.
So that's why I do that. Is like there's nothing there's no external calls, there's nothing else. It's just like it takes as an input the thing you're extending and then it outputs something else.
Yeah.
It doesn't do no
it doesn't change the state of the thing you're passing in either.
Yeah, that's what I was saying. No state changes is the word I was looking for. But yeah, no state changes in the object you're passing in. Just you pass it in and it returns then the converter especially returns the conversion, or in the validator it returns true or false.
Now, have you played with type converters in .NET by any chance?
Yes.
Okay. And I understand why you're like, I don't want to, I don't want to use those as the first thing either. It's like, I'm just going to get it done. And then if I have to, I'll come back to it.
Mm-hmm.
But yeah. So another thing you need to do after you've gotten this far is you need to build a wrapper, and it's kind of like a service locator instead of directly calling the container. And the reason I suggest doing this is putting a layer in between gets you a few advantages while you're going through this process. First of all, it abstracts you from that container so that you're not out of luck when you find out that it doesn't work well and you have to replace it.
Mm-hmm.
Because in inversion of control systems, like you'll get a ways in sometimes and you'll be like, oh, I can't do this one thing that I really need to do. And it's going to be thousands of lines of code if I can't. So having that separator kind of protects you a little bit from that because you really don't get to evaluate that until you've just slammed into the wall on that one.
Mm-hmm.
It also gives you a place where you can place logic around object creation that will eventually migrate to the IOC container itself before you're entirely sure what that logic will be.
Yeah.
Because now you're separating that out because there's probably lots of invocations of your type all over the app, and there's different logic around that, some of which is duplicated, some of which is slightly different, and you need to figure out why. This lets you deal with that without cramming that stuff into the IOC and then having to deal with the problems of the IOC on top of that and not knowing which one is the actual issue.
Yeah, when you're talking about this, I'm thinking of working with InHibernate and the model mapper wrapper. One thing, love saying model mapper wrapper because it's just fun.
You need an abstract factory model wrapper. I think that's
no, this is C#, not Java.
Yeah, I know. There's probably some Java guy going, what?
See, I said InHibernate, not hibernate.
Yeah.
Sorry, Java guys. It's fun to pick on y'all.
Yeah.
Yeah, no, it's like I think of that because I've run into a lot of issues where I would forget to put the mapping that I just created in the wrapper. But I also thought about it. I'm like, wow, it's so much easier having this wrapper than having to be like, all right, put in the code in every little location that calls that mapper.
Yeah. And so you're going to want to do that. I mean, the idea here is this is a utility class for you so that you can get through the rest of this process and stay sane. You're eventually going to throw this away.
Yeah. You want to make sure to add logging here. You want to log and instrument these calls and have both things be configurable. And this can make it a lot easier to troubleshoot how your code might use your IOC container in the future without dealing with any of the wrinkles that your container will obviously have.
Yeah. IOC container code tends to be a very complex beast because of the whole dynamic invocation and, figuring out which constructor to use to wire something up and just all the stuff that goes in there depending on your language. You're unlikely to understand all the underlying reasons the first few times you use a particular container. And by the way, when the version changes, there's new reasons. So because you don't know that information, you are taking steps to get away from having that problem. You're going to learn a lot by getting burned, and this layer makes it easier to recover from getting burned.
You also want to move all calls that create instances to use the wrapper method, one per type.
Right. So you would do like a get database connection, get people repository, get, or you could just call it people repository.
Yeah.
And you can do it with a property, you can do it with a method. The idea here is instead of directly mimicking the interface of the container, you do one per type so that you can troubleshoot that particular type. You can set breakpoints, you can see what's actually happening and not get a whole lot of chatter. This also makes it a lot easier to refactor away from this class in a piecemeal fashion so that you're not directly calling through. It also makes it easier to swap out the container when you find out that it's junk because now you're not tied to that interface anyway.
That's a good point. So the next thing you want to do is to carefully examine your logging and instrumentation output for expensive operations and to what goes in and out of your service locator wrapper.
Right. So you're going to want instrumentation and logging so that you can actually track what is occurring. And once you have that in place, collect a system baseline before you start screwing around with stuff. Remember, the goal is to make the system better, and you need to be able to prove that it's better because you're spending a bunch of time, which is money, to make this happen. This is really important, especially if management doesn't understand why you're doing this. Real data can get them off your back, provided that you can prove that, hey, I'm making this better. I'm making this part of the app faster. I haven't made it worse, because you're also going to get accused of that. So go ahead and plan ahead for that.
You're also going to be surprised by how often some of the types are being created. And one of the first things that you'll notice is that at least some classes are being created an order of magnitude more often than you thought.
Yeah, it's nobody thought about object lifetimes before you started this process? Probably. You might have had a real good developer back there somewhere, but there's probably been others since them. You're going to get surprised, and you need to plan on that. When you find these things, take note of them and point them out to people up the chain of command along with why they're a problem, because you're proving the value of what you're doing, right? This is a business process thing, not just a coding thing. You'll also find that certain types take a surprising amount of time to create. And you'll be going, why does this date time, doohickey class take so long to create? And you turn out that, oh, well, it's looping to create all the days or some crap like that under the hood. And you didn't know. That's a personal example that I've been through. That's why I'm laying that one out there. You'll have to examine how frequently these types are created to determine whether this slow allocation is a problem or not. But whatever the case, you need to take note of it, because you have to be really careful how you manage these objects' life cycle as you go forward so that you don't create a bigger problem.
So the next thing you want to do is to start updating constructors to take dependencies into account. And then mark your old constructors as obsolete. Do this from the bottom up, starting with the simplest types. These types tend to be used by other types further up, so you need to handle them first anyway.
Yeah, this will also simplify the types of problems you run into as you transition to more modern practices. I'm just telling you from experience, it's not fun running into a challenging IOC bug while you're dealing with a complex use case in your app at the same time, because you don't know which one's the problem. So if you get all the simple stuff out of the way, hopefully you've gotten those nasty bugs and found them with a simple use case to test against. Otherwise, you're just going to get something nasty and you're going to spend a lot of time on it, and it's really awful. The other thing this does, especially if you're leading this effort, the rest of your team may not really know how to do this stuff. So if you start with the easy cases, it makes their learning curve easier, which means you get more help.
Yeah, I will be honest. That's one of the things I have learned the hard way is, I do a lot of my own study and stuff, and I'll jump into some pretty heavy things at work trying to fix them or trying to make changes. And I have learned not to do that, to start off with like a simpler thing that I can show, all right, hey, here's the few changes I made, the, 3 or 4 things that I changed to improve this, and here's why, and here's what it does. And when you can do that and they can follow along with you, then when you go into doing some of the more complicated things, they're like, oh yeah, that's kind of like when we did the simpler one over here. Wait, why are you doing it that way? Rather than being like, oh my goodness, what are you doing?
Yeah. Like the first time you introduce, generics and delegates and expression trees and, like IOC and, whatever your new data access framework, like if you hit them with all that at once, your team's going to cry and they're not going to want to go with it because it's too complex. It's too painful. So if you just got to think about the interpersonal psychology here.
Yeah. No. You may want to create new types as you go just to help add some flexibility.
Yeah. For instance, in .NET, there's lots of people that'll go, okay, datetime.now. And they do stuff with the date and they do calculations off of it. Well, that's cool until you run into, for instance, leap years. And you're like, what is this app going to do on a leap year? Or, if I have some arbitrary date and I'm starting a sale on that date, can I make sure that code works? I had a fairly expensive mistake early in my career because we were pulling a date that was a string and converting it. We were seeing if a date was before or after a certain date to schedule when a sale went live. And it turns out that if you have dates as strings, they don't sort the way dates as dates do.
Mm-hmm.
We would have known that had we had a mock to test against instead of doing it off of datetime.now. So you're probably going to want to start kind of doing this sort of stuff. Anything that's a direct interaction with the system or your runtime environment, you're probably going to want to wrap so that you can mock it, just so that you can test.
Yeah. Speaking of testing, this is a point where you really want to strongly consider adding tests to the process. Remember, you're making fairly deep changes to the software, so having thorough tests is really going to reduce your stress. Like, one of the issues, like I mentioned it earlier with trying to mock something that's not overridable, was because I was trying to test something, and I was like, no, I am not comfortable putting this code out there until I have tested it. And it's something I've learned the hard way.
Yeah,
a lot of us have.
You really have to be very uncomfortable with IOC type changes, especially for this, because it tends to be large and sweeping changes. It's like, hey, I'm changing the way I'm creating this type, but this type is used in 400 different places, and I'm changing all of those. And there's downstream effects in all of those.
Yeah.
So you got to be super duper careful, or you're going to have a bad time. So speaking of having a bad time, now comes another fun part. You've done the parts that are easier and cleaner because it's just the developers interacting with the developers. Now we're going to bring the people that ruin all the things in. That would be the users. I'm serious. You start by converting a single thin vertical slice of your app to use IOC all the way through. The reason you leave this for last is that these type of interfaces tend to be the things that orchestrate the rest of the system. So the rest of the system has to already be in that state for this to be a good test. They're also the points where your code tends to get called by external frameworks. So, like for instance, in .NET or other web app type things, you have a web server that is calling and loading up your code.
Mm-hmm.
And you've now got an external system interacting with you. And it can be anything from that to a desktop operating system. The systems that call into your code, though, may not fully utilize your dependency injection and inversion of control setup. And this may require custom code to resolve.
Yeah. So this means getting your IOC container configured in such a way that it works with your framework.
If you can.
Yeah. Usually there's a lot of configuration that has to happen so that the calling code knows how to talk to your framework. Sometimes this configuration may have to change between different environments. So you have to be prepared to deal with whatever configuration management tools you're going to be using.
Right. So for instance, if you have a desktop app, your environment, if you're a Windows, you're probably Windows 10, right?
Yeah.
Give or take. However, your QA person, they're running it on Windows 10, but they need some special hooks because their QA software is pushing stuff at it. That's now in the mix for you as well as a developer.
Yeah.
And you're not going to find this out probably until you just slam into it. You might also find that constructor injection can't work and that you have to use a different strategy in this part of your application. For instance, Windows Forms. If you're using older school apps, the constructors, you can't pass parameters in there because when you do, the WinForms designer just falls over dead. It crashes Visual Studio's designer. And that's what you use to lay out the tool, all the buttons and stuff.
Yeah.
So you can't do that. So you have to do things like property injection instead. And you may do property injection there and then do constructor injection all the way, rest of the way down.
Yeah. You'll probably run into types that can't be injected for whatever reason.
Yeah. So my favorite example of this is old school ASP.NET is the HTTP context. The reason is because like your controllers, your web forms, your API endpoints, they tend to use that. And the base classes they inherit from also use it. And it's not injectable. So it's HTTP context, which is static, .current, which is also static. And that's what they're calling. You have no interception opportunity here.
Yeah, you can't really do that much either in .NET Core. This is what I've been talking about with the non-overridable object. Ran into this the other day. I was trying to test a file upload endpoint by mocking a multi-part form data coming in.
Oh
yeah, it was.
Yeah, boy.
So I got it to work. This is the really cool thing. I got it to work eventually. So I was able to mock HTTP context, and then I had to create a new. So like, I created the controller, and then I passed in a new controller context to that with the HTTP context object, but I couldn't just pass in, like just set that. I had to create a new controller context and then pass in a new action context with the HTTP controller. So like I had to go back several layers to base classes to create that and then pass it up through. But once I got
old
that,
school.net, you couldn't.
Yeah. Once I got that though, it was possible to do it, but it was a bit of a janky way around it.
Yeah.
But I had asked several other developers at work about it, and none of them were like, they're like, I've used mock and I've done this stuff, but I've never tried to do that. One of them was like, I think I have a friend in the private sector that can do it.
Yeah. I think I know who I would contact.
Yeah.
Over that. But yeah, I would try not to do it because, like, unless you want to learn profanity in a foreign language, like, because you're like tired of using the same ones in your own language. So you go and get somebody else's. It's just not, there's just types that are unpleasant. And the other thing is a lot of times stuff way down under the hood of your own framework is calling that stuff too. And it's doing it in a way that you can't get into, or you may have to directly hook into parts of your runtime framework in some weird way. And, this can be as screwed up as having to write stuff in C++ that messes with the .NET garbage collector so that you can do stuff. I've seen people do that before too, because they needed to pass a memory pointer for where a function was for creating something that then created the actual thing that they wanted to create. And they had to hook all those steps all the way back and use something outside their framework to get back into the part of their framework that they needed to get into. Mm-hmm. And that's way back in the day. But basically what happens is you often have a limited amount of control over how certain parts of your code are going to work, regardless of anything you've done elsewhere. And you're just going to have to accept that. Now, the other thing that happens here is you get object lifecycle issues that become apparent now that you're interacting with users. So you're dealing with programmers, however ill-behaved they are still programmers. They kind of think the same way. Users do not do this.
That's so true.
Yeah, it gets really interesting because user behavior varies a lot. You really need to be careful about situations where expensive objects or operations are kicked off by users. As these are places where a user could conceivably overload your system. And by the way, if your app is legacy, you probably already have those and just don't know they're there. Mm-hmm. But you're going to find it, and then you're going to get blamed because it became apparent when you were around.
Yeah. Also be careful about intersections of object lifecycles and threading, as this part of a lot of systems tends to dispatch to background threads to do work while keeping the front end sort of responsive.
Right. So like, for instance, in Windows Forms, you've got a thread for the front end of the app, and you're doing work in the back end, and you're marshaling results back across. Mm-hmm. Well, what happens if the background thread is like, okay, I'm done with this, deallocate it, and the foreground thread still has a reference to it and tries to call it?
Yeah. Okay.
So you can get some very, very screwy things that happen, or you get things where the state is changed in one place and the other place doesn't know.
Yeah.
So, like, all your threading fun gets in here. So be really, really careful about that. Mm-hmm.
So the final thing that you need to do is to start deprecating methods on your IOC wrapper class and remove them as they become unused. A lot of the wrapper methods that you built early on are probably already unused at this point, so it's time to get rid of them, kind of applying the Yagni principle backwards or retroactive.
Yeah, and you wait till this point, too, because you may need them. Like, you may have removed all the references, but don't delete them before this point. Like, delete them once you get to this point.
Yes.
Because you're going to find that you have to put it back, and it's really annoying because you're like, oh, I'm going backwards. Instead, just leave the dead code. Yes, we know it's dead. Tell FXCop to shut up about it for a minute. and, tell whatever your linter is, whatever you're using to check that stuff. Yeah, I know that it's there. Leave me alone. And then get to this step, and now you fix it.
Mm-hmm.
You've probably eliminated a lot of the calls to most of the methods on your IOC wrapper by this point. As you start migrating stuff over to your dependency injection container. Unless you were exceptionally disciplined, you probably didn't clean up the dead code anyway. So this is one of the things that you need to do. After that, you're going to have a list of things that you still haven't fixed.
Mm-hmm.
There are 3 approaches, and you're going to use those based on the circumstances you encounter. Some of the remaining items are just simply weird corners of your app that you missed earlier on. Just go ahead and resolve those the same way as you did everything else. There's always going to be stuff like that you missed because it's some feature that nobody ever uses. Every app has it.
Yeah.
Go deal with it. Some of the remaining items are going to have a lot more logic around the way that you're creating the type that is being used. If you can't get that logic into your IOC container, use a factory pattern and make that come out of the IOC container.
Mm-hmm.
You might also find that the types that you're trying to create are no longer used themselves. So not only is the method that creates them not used, but hey, this thing's dead and who knows how long it's been dead. It's just, it's cruft that's built up in the app. It's a legacy app. It's like genetic damage in a, really old family line. It's just there.
Yeah.
Get rid of those.
Wow. So you should be able to get rid of your IOC wrapper class after this and either use built-in IOC or call the container. Then you need to look into ways to hook instrumentation into your IOC container. This will help you troubleshoot in the future. You probably should replace the instrumentation from your wrapper class with code that directly interfaces with your IOC container. You're still occasionally going to need to instrument things.
Right. So the container may raise events when objects are created. It may do it based on type. There may be a filter type thing. There may be internal logging. There's a lot of different ways that they could do this, but it probably has something because the guy that wrote the thing has to be able to debug it in a production environment where he can't set a breakpoint, or in a multi-threaded environment where it doesn't matter if you set the breakpoint because you just changed the app because you changed the timing.
Yeah.
Speaking of timing issues, you're going to run into them as you try to make your logging framework play nice with the IOC container. It's just the nature of the thing because you're potentially using that IOC container as part of your logging or as part of building the message or as part of some other thing. And if it's not working, you can't log. You're going to have to play with this at this point. The other thing you need to do is you need to make sure that your log verbosity is configurable, both at the level of severity and based on the object type that you're creating. So you want to be able to say, hey, if it's an error, write this out. If it's just a warning or below, don't bother me until I turn it on. You also need to have kind of like different log topics in there to say, okay, when I create a SQL connection, log that.
Mm-hmm.
But don't log when I create a data table or create a datetime wrapper doohickey. Just, log it on that one type so that you can troubleshoot these things in the future. So you're going to have to be kind of careful about how you do this and intentional so that you can debug later.
Mm-hmm. I like to use the built-in logging. Like I've been doing a lot of .NET Core, which has a built-in DI framework. Like it's built for dependency injection.
Right.
And so what I will do is I will use the Microsoft logging extensions.
Yep.
And that way I can pass, like I don't have to worry about it. The DI framework passes in the logging itself. But then in the startup class, I tell it, hey, all right, point logging at this logger.
Right.
And then I set up my logger. So then I'm using the built-in system. So it's got a lot of that stuff already taken care of in it. And it's got those controls there. And then it points to the logger that, sends it to where I want it to go. I really like the way it's built. It's a lot easier to do logging the way it's built into .NET Core than it was in .NET Framework.
Yeah.
And at least the last time I did it.
Well, because .NET Framework, that came out of the late 90s.
Yeah.
And they've glued a bunch of stuff on there and it finally got to the point where it's like, hey, we've got to do deep stuff to fix this. Cleaning up code in older apps is a ton of work and you simply cannot do it all in a short period of time. There's a bit of art and science to the process of cleaning up legacy systems to make them more maintainable. You have to be smart about the way you handle this work, both because of the risk of breaking things and because of the way office politics tend to work. However, if you do it well, you can drastically improve the functioning of nearly any old crusty app that you run across. That pretty much wraps us up. What do you have for us for tricks of the trade?
So just like there are a lot of things that we don't think about being in older applications, there are a lot of people working behind the scenes that we don't think about until we need them. Earlier, we were talking about being stuck inside and like being in IT and having a lot to do. In this time of global crisis, those on the front lines, the doctors, nurses, and the first responders are getting a lot of praise. But let's not forget about the lab rats diligently working to create a vaccine, or those in the service industry who are not getting the hours or tips that they need to pay their bills, but still going in and making food for delivery and pickup. Something as simple as saying, thanks, I appreciate you, to a person at a call center can make their day when most of who they deal with are angry people. I had to call my cable company the other day to cancel a service. They asked me to do a free trial, so I did a free trial on this streaming TV service. I didn't realize how crazy hectic my life was going to get. I'm like, I've had this for free for several days and I've not even touched it. I haven't even configured it yet. So I just called to cancel, and I was being polite. I was like, hey, thanks. I really appreciate, all that you guys are doing, working hard when everybody else is kind of, not getting to work as much. And just saying that to someone who deals with angry people all the time really made a difference. Like the lady I was talking to, she was like, that really made my day. Thank you. Also, thank your infrastructure and your operations coworkers, guys. They are overloaded with work as people are all trying to log in and work remote. I know ours have just been constantly busy, yet still responsive when I had a question or needed a connection to a database or something like that. So,
yeah,
you know what? These guys are putting in a lot of extra hours. Just reach out and say thanks to them. And just a simple thank you, I really appreciate it, can go a long way. That's all I got.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.